Hello teachers! Welcome back to Chapter 3. This is our final section in Chapter 3. We're going to be discussing Section 3-5, Division of Whole Numbers. Students will be able to understand and explain. So here are our course outline, the meaning of division through various models, the inverse relationship between multiplication and division, the special cases of division by 0 and 1, division algorithms, including the standard algorithm. Notice I have, I would say highlighted, but not really. I have grayed out division and number bases other than 10. This shows up in the textbook, but I would like to skip this topic for now so we can really focus on division of our regular base 10 numbers. If it's something I decide to go back and discuss later, I'll add it as a separate video. I've also removed the homework problems regarding this because I found myself bogged down in this topic and not able to focus on really, I think, the most important thing, which is the division algorithms, including the standard algorithm. Finally, mental division skills and estimation techniques, which I do think are very important. So for now, we're going to skip division in bases other than 10. I know you're so very disappointed. We have added, subtracted, and multiplied in bases other than 10. So let's move on. So division of whole numbers, we have 3 models for division that we're going to talk about in detail. The first is the set partition model. What we do here is the set of elements representing the dividend is partitioned into the divisor number of subsets. So remember from your previous math courses, the dividend is the number being divided, and the divisor is the groups you're dividing it into, or the subsets you're dividing it into. So be sure you know the difference between the dividend and divisor. The missing factor model. A divided by B is a unique number C provided that B times C is equal to A. So we use the missing factor model to explain that division is really the opposite or the inverse operation of multiplication. And then you have the repeated subtraction model. The divisor is continually subtracted from the dividend until only the remainder is left. And the repeated subtraction model is really what gives us our current standard model for long division. So we're going to take a look at that in detail as well. So let's take a look at this set partition model in detail. Suppose we have 18 cookies and we want to give an equal number of cookies to each of 3 friends. So we have a pack of 18 cookies and 3 people to give these out to. How many should each person receive? So what you want to think about this is your subset or your partition are the people. So Bob is going to get some cookies, Dean is going to get some cookies, and Charlie is going to get some cookies. Now, one thing is you can imagine doing is you can take each cookie out one at a time. So I'm trying to highlight this picture. There it goes. And then we put a cookie here, and we put a cookie here, and we put a cookie here. And we continue to do that. Put a cookie here. Put a cookie here. You see what I'm doing? Put a cookie here. Until we get all the cookies. Uh-oh. I'm leaving some people out, aren't I? Divide it up. Let's make sure we catch up. So notice they have 3 cookies each now. And then a cookie here. A cookie to Dean. And a cookie to Charlie. And then we have a cookie to Bob. A cookie to Dean. A cookie to Charlie. Notice I did this out of order, which is terrible. Don't do it that way. There we go. But notice we have 6 cookies per each subset. Okay, so we gave Bob 6 cookies, we gave Dean 6 cookies, and we gave Charlie 6 cookies. Notice there are no cookies left over. That is very important with all of your models of division. If you have cookies left over, we could consider that the remainder. What would we do partition-wise if we gave Bob 6, Dean 6, but Charlie only had 5? Well, we would have to pull 2 cookies out because we want them to have the same number of cookies. Of course, that would work with say 17 and not, or 16 and not 18. But again, partition one at a time. When everybody has an equal amount without more than your subsets left over, then you're finished with your partition. Next, we have the missing factor model. So once again with the cookies, each friend receives C cookies. Then the friends will receive 3C or 18 cookies. Therefore, 3C equals 18. Since 3 times 6, so again, there's the answer to our division problem right there. Since 3 times 6 is equal to 18, we have answered the division computation by using multiplication. Your students will be able to do this because they're going to know their multiplication facts. And again, this is very important for students to know their multiplication facts, if no other reason, to be able to divide and think about the missing factor model. Now, before we move into that third model, the repeated subtraction model, let's talk about the definition of division. What does that really mean? Well, for any whole numbers, A and B, with B not equal to 0, notice we have A divided by B. I'm trying to highlight it. There we go. A divided by B equals C. If and only if C is the unique whole number such that B times C is equal to A. So make yourself an example for that. Let's just make one up together. We know that, for instance, 10 divided by 2 equals what? Okay. Then if you turn that into your multiplication, okay, which is this definition, we know that, I'm going to write down here below, 2 times what number equals 10? That's the missing factor model right there, and that is the definition that is used for division. It says the number A is the dividend. So remember, the number that you're dividing up, for instance, 10, here is our dividend, and our divisor is your B value, which is, if I do this in a different color, you see that our divisor clearly is 2. And our answer to the division problem is our quotient. So the quotient is our result right there. Now let's recap just while we're up. Okay, addition, the answer to an addition problem is sum, and the values you add are called add-ins. Right? Subtraction, the answer is called the difference. What are the two values for subtraction? You remember the minuend and the subtrahend. The minuend is the larger number right now when you're dealing with whole numbers, and the subtrahend is the value being subtracted. When you multiply, the answer is called a product, and the two values you're multiplying together or more are called factors. And now we've got this definition of division where we have a quotient is the answer, and you have a dividend and a divisor, and they do not mix up, and we'll talk more about that in a minute. A divided by B can also be written as a fraction, yes, so A divided by B is the same thing as A over B. You could even read this in pink down at the bottom as A divided by B. Notice when you set it up with the long division bar, and now I've even looked up the name to that, and there's two parts to it, and I can't recall. I could look it up, or you could look it up. The bar over the top is called one thing, and this side thing is called something else. We just look at it as like a long division bar, right? Again, underneath your A value, that's your dividend. That's what you're dividing up, and out front, your B value is your divisor. And of course, the answer, which goes on top in this standard model of long division, is your quotient. Now let's talk about the division algorithm, and we're going to go in through this explanation before I even show you exactly what the division algorithm is. So hang with me just a minute. Suppose we have 18 cookies once again, and want to package them in cookie boxes that hold 6 cookies each. So this is a different problem. So we're dividing up our cookies into boxes. How many boxes are needed? So as you can imagine, you got this big box of cookies. How about we put 6 cookies in the first box? And so we go on to say if one box is filled, then there are 18 minus 6, 12 cookies left. So this is the first box. Again, highlighter. There, one box, and we have 18 minus 6, 12 cookies left. Let's fill up another box, shall we? Okay, so one more box. This is our second box. We're going to take the 12 we have left over, subtract 6 again, and then we have 6 cookies. And then the last box, can we put 6 cookies in the box? Sure we can. Last box, 6 cookies. Again, that's going to leave 0 cookies left. And how many boxes do we have? That's our 3 boxes right there. So this is how the division algorithm works. And here's your division algorithm. Now, it might not feel like what we just did, but really this is exactly what's going on here. So given any whole number A and B, as long as B is not equal to 0, then there exists unique whole numbers Q. Remember Q, we're going to represent, that's our quotient. Okay, and R is your remainder. So what we're saying, this is like our box of cookies over here. This is A. Okay, we're dividing it up into 6 cookies with 3 boxes, because 3 was our quotient, our answer earlier to the division problem. Our remainder happened to be 0. Now look at this expression over here. Okay, it says 0 is less than or equal R. It's really an inequality, is less than B. Why do they say that? Well, remember, your remainder has to be less than your divisor, right? Because if your remainder was larger than your divisor, that means you could have filled another box. So your remainder is always a smaller number than your divisor. Now remember, with our box of cookies, we had a 0 remainder. That's what this next statement says. When A is divided by B and the remainder is 0. Okay, highlighting that. The remainder is 0. We say that A is divisible by B. So again, your dividend, okay, is divisible by your divisor, and that B is a divisor of A, or that A divides B. So when you have a remainder of 0, you could say that A divides B. I know when I was growing up, we would say a number went in evenly, which meant it had a 0 remainder. But a better way to say that is that A divides B. Even means something entirely different, right? You know the even numbers. So it does have to do with divisibility, though. Don't get me wrong. But let's say A divides B instead of a number went in evenly. So this is your division algorithm. Anytime that's referenced, this is what we're talking about. It's also a way to check your division problem. Let's talk about that real quick, just while I'm there, because it doesn't show up in the book or in the PowerPoint. So look at an example where we have long division and we have 3 divides into, let's do 14. Now let's talk about what our parts are here, right? The 3 is your divisor, the 14 is your dividend. And we're going to use the standard model for long division. So we say 3 divides into 1. Now what we're really doing is saying how many times does 3 divide into 10, because that's in the tens place. And we know 3 divides into 10, but we really should look at all the way over here at 14. So it divides into 14. Well, we put a 4 above the 14, the ones place, because 3 times 4 is 12. That's the closest we can get to 14. Then remember, we subtract, so 14 minus 12 is 2. And if we're dealing with whole numbers, we are finished here. So we're not worried about fractions. What we're doing is we're going to say that the quotient is 4 and the remainder is 2, correct? So we have, once again, our dividend is 14, our divisor is 3, our quotient is 4, and our remainder is 2. Now, if we put this in the division algorithm, and remember the division algorithm is right here, A equals B times Q plus r. So our a is our dividend. So we have 14 is equal to b, which is our divisor, 3 times q, which is our quotient, 4, plus r, which is our remainder, 2. And if you check that, and you're going to want your students to do this, you have 3 times 4 is 12. 12 plus 2 is 14. So that is a way to use this all-important division algorithm. All right, so we have an example. If 123 is divided by a number and the remainder is 13, what are the possible divisors? So this is a very interesting problem. Now let's talk about what everything is, and I want you to remember the division algorithm. Remember, it says that A is equal to B times Q plus R. And if you want to think about this in terms of words, and I highly advise it, remember A is your dividend. This is the value you're dividing up into subsets. B is your divisor times Q. Q is your quotient, which is, remember, is going to be the number of things in each of your subset, plus R is the remainder. I really like the idea of writing this out in words. Now, how does that apply to the problem we have? If 123 is divided by a number and the remainder is 13, what are the possible divisors? So if you set this up in your division algorithm, 123 is your dividend. That is the value you're trying to divide up into subsets. Equals. Now notice, they want to know the possible divisors, so we don't know B. Okay? Do we know the quotient? I'm afraid we don't, right? So we don't know Q either. Is that okay? We're just going to keep going with it. We do know the remainder R, so plus 13. Now our approach here is to try to solve this as an algebraic equation. You have those skills. And try to get at least the B times Q isolated. So what if I subtract 13 from both sides? Now, if you're teaching this to students, it would be a little different. We don't have these algebra skills, but students do understand that they can manipulate this way. So you could still talk them through this, but this is more for you rather than a student problem, okay? So 123 minus 13, we know that's 110. And that's equal to B times Q. Now we need to think about, because we have two things we don't know. We don't know the quotient and we don't know the divisor. But it's asking the possible divisors, not the possible quotients. But we need to think about what two whole numbers can we multiply together to equal 110. So be thinking about that. Now I'm going to show you the typed up version of this. We haven't finished the problem, so hang tight. But the typed up version of this, and again the lead in, before I even scroll over there, the lead in again is 110. Really I'm asking, what are the factors? Here's something else, right? Your remainder is 13. Now that means that your B has to be greater than 13. Why is that? Right? Because your remainder is never allowed to be bigger than your divisor. Let's go back to the division algorithm that I wrote all over. Let's talk about that real quick. Notice it says where 0 is less than or equal to R is less than B. Your remainder must be smaller than your divisor B. So we've got to keep that in mind. But again, I'm going to go back to the typed up version of this. This just re-explains what I wrote down here in a different way so you have it. All right, so the solution. If 123 is divided by B, then from the division algorithm, they just jump right in, don't they? 123 is equal to B times Q plus 13, and B must be bigger than 13 because your divisor must be bigger than your remainder, always, your B value. Then they go on to say from the definition of subtraction, and that's when we subtracted 13 from both sides, right? 123 minus 13 is 110. So BQ equals 110. Now, what are the factors of 110? That's where I left you off, and I've been getting you to think about that along the way as we summarized. So next I have a table that gives us the factors of 110 right here. So let's just take a look at it. We know 1 times 110 equals to 110, of course, right? So does 2 times 55. So does 5 times 22. And finally, so does 10 times 11. But remember the restriction on B. B has to be bigger than 13 because the remainder was 13. So that means 110 could be a possibility. 55 is bigger than 13, so that's a possibility for your divisor. 22 is bigger than 13, that's a possibility. I'm not going to highlight 1, 2, 5, 10, and 11. Why? Because all of those are smaller than 13. Okay, so we see that 110, 55, and 22 are the only possible values for B because each is greater than 13. And that answers the question using the division algorithm. Some important notes about division. How do we divide by 0 and 1? We know that we don't divide by 0, right? So we're going to let n be any non-zero whole number. Then n divided by 0 is undefined. 0 divided by n is equal to 0. And 0 divided by 0 is undefined. But why? Why is that the case? I know you've heard it forever and ever. You're never allowed to divide by 0. But why? So let's address this using the division algorithm. Now I'm going to write at the bottom of your screen the division algorithm. If you'll remember, that's A is equal to BQ plus R. Okay, A is equal to BQ plus R. Now, here's what I want to think about. In these situations, let's ignore R for the moment. Okay, let's just ignore R. Not an issue. All right, my A is remember, that's my dividend. My B is my divisor. And Q is my quotient, which is my answer. So when I look at the first statement that says n divided by 0 is undefined, let's fill in what we know. Our n, that's our dividend. That's what we're dividing up. So I have n is equal to, that goes in my A position. B is my divisor, right? B is my divisor. I'm dividing my 0, so I'm going to replace B with 0 times Q is my quotient. They tell me it's undefined, but let's take a look at it. So I'm going to put question mark there, right there. Now, it says right here, n is a non-zero whole number. Now, here's the problem. On the right over here, when I multiply 0 times some non-zero, well, I don't know the answer. 0 times some number is equal to a non-zero number. We know that 0 times any number is equal to 0. There is no way we can do this. This is impossible. I'm going to write that in red. This is impossible to put any number here, times it by 0, and it equal to something that's not 0. I think it might even help you more to see this in terms of just actual numbers. If I gave you instead 6 divided by 0. If I use the division algorithm, that's saying 6 is equal to 0 times what number? What number are you going to put in that blank to times 0 to equal 6? It's just never going to happen. There is no number right here that I can multiply times 0 to give myself 6. And this is exactly why this is undefined. And I hope if that's ever been confusing to you, that it's straightened out now. Think about division as a multiplication problem. In other words, use the division algorithm, and you will see that that's not possible. Now let's look at the next example. So again, let's use the division algorithm. 0 is your dividend. That's your A value. So I have 0 equals, okay. Now B is your N value. You're dividing by N, so N times what number for your quotient? What number could I put in here for question mark to multiply by N to make it equal to 0? Well, I know you know the answer to that. That's 0, right? Because anything times 0 equals 0, and this will work out. So that's why 0 divided by a non-zero number is okay. It's equal to 0. But on the other hand, N divided by 0 is not okay. It's undefined. Now, you could also think about this in terms of the partition method, right? Especially the second one. If you have 0 cookies and you're trying to divide them up into 3 subsets, that means everybody does not get it. Nobody gets a cookie. Not everybody does not get a cookie, but nobody gets a cookie at all because you don't have any cookies to divide up. Now, partitioning in the first example is strange because you have, say, 18 cookies and you're dividing that into 0 subsets. That's not possible because you don't have any subsets to put the cookies into. So that's just weird. But now the division algorithm explains the undefined very well. And then one more time with this division algorithm, let's attempt to do 0 divided by 0 using the division algorithm. All right, so again, 0, this is your dividend. This is your A value. What you divide by is your B value, your divisor. Your quotient is what you're looking for. So I'm saying 0 equals 0 times what? Okay, now at first you might be thinking 0 works, so does 1, so does 2, so does 3, so does it. It's in calculus, it's called an indeterminate form. As you can imagine why, because it really could be anything. But since you're dividing by 0, we're going to stick with the convention that that's undefined, because it's still not defined. We still don't know. You're still not allowed to divide by 0. Okay, never divide by 0. This, and this is out. But 0 divided by a non-zero number is perfectly okay. Now, I'm sure you've thought about this in the past, relating multiplication and division as inverse operations. Now, we know from a previous section that addition is the inverse operation of subtraction. We know this. Well, what is addition? Addition is just repeated, actually, multiplication, this is backwards, is repeated addition. Okay, so if you repeat addition, it gives you multiplication. What if you repeat subtraction? That does give us division. We have the repeated subtraction model, which we're going to go into further detail in a few minutes. That brings us to the fact that multiplication is the inverse operation of division. Now, we even see that from the division algorithm. We're changing a division problem into a multiplication problem. So addition and subtraction are inverse operations, multiplication and division are inverse operations. And then they're related by this great box, because multiplication is just repeated addition and division is just repeated subtraction. Now this seems probably just way out of the blue, but we have a property of exponents that was actually covered in the previous section, so this is just a reminder. But when you divide, when you have a to the m power divided by a to the n exponent, then that's equivalent to a to the m subtract n exponent. Now, I think an easier way to look at this, and this is very algebraic, but we know that the fraction bar can replace the division bar, correct? Now, we saw, again, in the previous section, that's m minus n. But let me show you an example so you can see this live. Okay, what if I give you 2 to the 7th divided by 2 to the, let's do the 4th. Now, another way to think about that is 2 to the 7th over 2 to the 4th. Remember, the fraction bar and the division symbol can be used interchangeably. 2 to the 7th. Watch me write this 2 out 7 times. That's 2 times 2 times 2 times 2 times 2 times 2. I know, shut up. This was 1, 2, 3, 4, 5, 6. There's 7 of them. 2 to the 4th. 2 times 2 times 2. I need 4 of them. Now, if you'll notice, 2 divided by 2 is 1. This 2 divided by this 2 is 1. This 2 divided by this 2 is 1. This 2 divided by this 2 is 1. What does that leave me, y'all? Well, it leaves me 2 times 2 times 2, which is 2 to the 3rd power, which is just essentially 7 minus 4. When you divide, you subtract exponents. As a reminder, when you multiply, you add exponents. And there's that relationship again between multiplication and addition and division and subtraction. Now, I'm at my 30-minute mark, so I'm going to shut this down. I'm going to come back for part 2, where we look at base 10 blocks and the division algorithm. And then we'll talk about the standard model of division and then alternate models of division.